Okay, let's get going with this apportionment. So our first step here is to compute the divisor with Hamilton's method. Divisor is the first thing, and the divisor is going to be 24,680 divided by 20. So you're using the number of representatives. And I got 1, 2, 3, 4 is my divisor. And then you're going to compute the quotas. Quota, I'm going to just put it in a little column here next to this. And just to demonstrate this, once, you know what, I need to make some room, I just realized. Let's do this, there. So to compute the quotas, we're going to do here, 2124 divided by the divisor, 1, 2, 3, 4. So I'll do this for each of these numbers, and actually I kind of cheated here. Whoops, there we go. I'll show you. Earlier I set up a little spreadsheet, and I have those numbers right there in the spreadsheet. See, can I get rid of this? There. So you can see that I've already done the divisors. So I'm just going to write this in for anyone who downloads this. So I'm going to do 1.72 there. I think that's sufficient. And then, of course, we have the rest of these. 3960 divided by 1, 2, 3, 4. 8890 divided by 1, 2, 3, 4. And 9706 divided by 1, 2, 3, 4. And as I mentioned, I've already done this over on the right because I didn't want to sit here fumbling with my calculator. 7.20, 7.87. I think that will be sufficient. Okay, now that I have that, I can round down. One, 3, 7, 7. And then we're going to add those up. The total of those, it looks like, is 18, but I'm supposed to, I need 2 extras because I need 20. So extras, I need 2 more, and we're going to give the 2 more to the 2 largest fractional parts. And it looks like it's that one and that one get the extras. So we have a +1 here and a +1 there. And then the final apportionment will be 2, 3, 7, and 8. That's my answer. Oh, I have blanks here. 2, 3, 7, 8. 1, 2, 3, 4. Okay, so that's the easy one. And now we're going to do the hard ones. So the next one is Jefferson's method. Remember, with Jefferson's method, we always round down. And so what I'll do here is I'm going to make a series of guesses. So just to sort of get us started, hopefully I won't need any more than that for guesses. For a divisor of 1, 2, 3, 4, we already see over on the right in my spreadsheet, this is 1.7, which is rounded down to 1. This is 3.2. I know this isn't going to work, but I just want to have this sort of to establish the pattern. 7.9 rounds down to 7, and the total here is 18. So since there are too few, that I'm going to try a smaller divisor. So let's try 1100. Let me just move my spreadsheet over and notice that I've already got this set up so that I can do this quickly. Let's see, so let's get rid of that. And for the divisor of 1100, now you would do this on your calculator, of course. I have 1.9 for the first state, which rounds down to 1, 3.6 for the next one, which rounds down to 3, 8.1, which rounds down to 8, and 8.8 that rounds down to 8. And if I add up these, 8 plus 8 plus 3 plus 1 is 20. So I got lucky. Oops, there's 1100. So I got lucky with this one, but you might have to guess more. Whoops, I shouldn't have gotten rid of that. You might have to guess more or fewer times to get this right. But here I got lucky, and I got 1, 3, 8, and 8. And my divisor that worked is 1100. You might have chosen a different divisor, which is totally fine. Okay, with Webster's method, we're going to round in the normal way. And whoops, I didn't mean to do that. There we go. So with Webster's method, we're going to round in the normal way. Let's see if I can get that split view again. Come on. So let's go back to the original divisor of 1, 2, 3, 4. And there. So if we round the, here we go, we'll do the same thing. D is equal to 1, 2, 3, 4. Round in the normal way. Take those numbers over there and round them in the normal way. 1.7 rounds up to 2. 3.2 rounds down to 3. 7.2 rounds down to 7. And 7.9 rounds up to 8. And if you add those up, you do get 20. So there's nothing else to do. But if that didn't add up correctly, you would have to guess again. But here we got lucky on the first try with the standard divisor. And 1, 2, 3, 4 works. All right, let's do this last one. Frank, he ended up on a different page than the other people, but we'll do it. 5% simple interest, so the rate is 5%. The number of years, I don't remember what letters were used, is 6. And the original present value is 3,000. And so I'm going to do this, that the future value is the present value times 1 plus r times the number of years. There might have been a t instead of an n there. But anyway, either way you cut it, you're going to get the same answer. So in my case, it's 3,000 times 1 plus 5%. Let's write that like a decimal, times 6. By the way, another way of looking at this is here the interest per year is 5% times 3,000. Here, we'll get the answer first, I suppose. Let me get my calculator again. So let's see, 3,000 times 1.3. So I've got 3,900 here. But another way of doing this is to do 5,000 times, 5% times 3,000. And you get 0.05 times 3,000 is 150. That's how much interest you get per year. And 150 times 6 years is 900. And so 3,000 plus 900 is 3,900. So either way you cut it, you get the same way. So either this or this, two different ways of doing the same thing.